Hello students, a very good morning to all of you. Welcome back to the video lecture series of numerical methods in chemical engineering. We have started unit number 5, that is finite differences and interpolation. First of all, we studied about the finite differences. There are three types of finite differences. The first one was forward difference, second one was backward, and the third one was central difference. Then after we studied about interpolation. What is the meaning of interpolation? Interpolation is the process to find the value of the function for the intermediate values of the variable. Okay, that is known as interpolation. Okay, then we studied about the two types of methods that we have to study. The first method was equal interval and the second was unequal interval. What is the meaning of equal interval? If the difference in the values of x is same, that is known as equal intervals, and the difference in the values of x is not same, that is known as unequal intervals. So which two methods are included in the equal intervals? So Newton's forward and Newton's backward are included in the equal intervals, while the Lagrange's and Newton's divided difference method are known as unequal intervals. See, we have already studied the theory of Newton's forward interpolation and we have also solved one numerical on the basis of that. In today's lecture, we will solve one more numerical on Newton's forward interpolation and then we will start Newton's backward interpolation. Okay. So let us take one more example on the basis of the Newton's forward interpolation. See, what is the difference between that particular sum that we have solved in the previous lecture and this sum? The main difference is we have to find the interpolating polynomial. Okay, in that numerical we had to find the value of the function. Here we are not interested in finding the value of the function, we have to find the polynomial. So our answer should be in form of x. Okay, fine. So let us solve this. Okay, first of all we have to find the value of p. What is p? P is equal to x minus x0 upon h. X will be as it is. Our x0 is 1, so my x0 will be 1, so x minus 1 upon h. What is the value of h here? The difference between the values of x. What is the difference between the values of x? 1. So my p is equal to x minus 1. Fine. What is our next step? Our next step is to make the forward difference table. So what is to be written in the forward difference table? First of all x, then f of x, then first difference, second difference and third difference. Let us write the values of x first, 1, 2, 3 and 4. Then the values of y. Y is nothing but f of x. So my values are minus 1, 1 and 5. See, now we have to find the first forward difference. How I can find the first forward difference? This value minus this value. So minus 1 minus minus 1, that is minus 1 plus 1. That will be 0. You have to write the value in between these two values, right? See, 1 minus minus 1, that is 2. 5 minus 1, that is 4. Okay. Then again we have to find the second forward difference. 2 minus 0 is 2 and 4 minus 2 is 2. Fine. Then third forward difference, 2 minus 2, 0. Okay. See which values we have to take. In the numerical we require these values. The first value of the table, 1, 2, 3 and 4. See, this value is my y0. This is my del y0, del square y0 and del cube y0. Okay. We have to place all these values in the Newton's forward interpolation formula. So let us write the Newton's forward interpolation formula first. Which is the formula? See, f of x is equal to y0 plus p del y0 plus p into p minus 1 upon 2 factorial into del square y0 plus p into p minus 1 into p minus 2 upon 3 factorial into del cube y0. Now what is the value of y0? The value of y0 is minus 1. What is the value of p? Our p is x minus 1. And the value of del y0, the value of del y0 is 0, right? Plus x minus 1 into x minus 1 minus 1. So that will be x minus 2 upon 2 factorial is 2. And the value of del square y0. What is our del square y0? Our del square y0 is 2. Then after that, our del cube y0 is 0. So here I have to write 0. So simplifying this, my answer will be minus 1 plus, see this 2 gets cancelled, minus 1 plus x minus 1 into x minus 2. Fine. Minus 1 plus, if I will expand this, what will be my answer? X square minus 3x plus 2. So if you will simplify this, our answer will be x square minus 3x plus 1. So this is our required interpolating polynomial. Okay, let us derive the interpolation formula for Newton's backward. Newton's backward is also one type of interpolation with equal intervals, because the values of x are, the difference in the values of x is same, so it is also known as equal interval method. This is second type of equal interval method. The first one was Newton's forward and second one is Newton's backward. Okay, what is the basic difference between Newton's forward and Newton's backward? What we have to, when we have to apply Newton's forward and when we have to apply Newton's backward. See, when the function value is to be estimated for the value of x near the end of the table, then we have to use backward interpolation formula. When the forward was used, if we want to find the function value for the value of x at the beginning of the table, then forward interpolation is used. And if we want to find that for the value of x at the end of the table, right, then Newton's backward interpolation formula is used. Okay, in this also a function y is equal to f of x will be given for different values of x. For example, we are starting the values of x from x0, x1, x2, x3, where x1 is equal to x0 plus h, then x2 is equal to x1 plus h, or we can also call it x0 plus 2h. For these all values, the values of y are also given y0, y1, y2, y3 and so on. And if we want to find the value of y for any value of x that is at the near the end of the table, okay, let us consider that value to be xn plus ph. Xn plus ph, right? So let me write that. x0, then x0 plus h, x0 plus 2h, x0 plus 3h. Okay. Similarly, we are having the values of y as y0, y1, y2, y3 and so on. Okay, this is the end of the table. This is the beginning of the table. See, this is the beginning of the table and this is the end of the table. So if it is x0, then near the end, xn and yn will come. Okay. So if my value of, see, if I want to find the value of y for the value of x near the ending value, for example, I am considering x is equal to xn plus ph, then I have to find the value of yp. To find the value of yp at the value of x near the end of the table, xn plus ph, right? We need to derive the formula for Newton's backward interpolation. Okay, so this is the basic concept. So we are interested in finding the value of yp at x is equal to xn plus ph. Let us derive that. See, here also we are going to use the shift operator e of f of x. What is our e of f of x? E of f of x is f of x plus h, and we have to also use this relation. Here we are going to use this relation, E inverse is equal to 1 minus nebula, or I can also write it as E is equal to E is equal to 1 minus nebula inverse. Okay, we have to use this relation. Let us write the formula for Yp. What is Yp? See, Yp is nothing but f of xn plus ph. I can write f of xn plus ph is equal to e raised to p into f of xn. So it can be also written like this, e raised to p into yn. Now what is my e raised to p? What is the relation between E and nebula? See, I have to use this relation. So here I can write 1 minus nebula raised to minus p into yn. Okay, if I will simplify this using binomial theorem, I can write like this, 1 plus p nebula plus p into p plus 1 upon 2 factorial, p into p plus 1 upon 2 factorial into nebula square plus p into p plus 1 into p plus 2 upon 3 factorial into nebula cube, and so on, right? And this whole term is multiplied by yn. So if I will simplify this, my answer will be yn plus p nebula yn plus p into p plus 1 upon 2 factorial nebula square yn, and so on. So this is my formula. This is the formula to find the value of Yp at x is equal to xn plus ph, and for this we are using Newton's backward interpolation formula. See, this formula is known as the Newton's backward interpolation formula. Okay, let us solve a numerical on the basis of this. This is the given numerical. The tabulated values are given 2.53, 3.54 and 4.5, and the respective values of y are also given, and we have to find the value of y of 4.25. See, 4.25 is near the ending value, so we have to apply Newton's backward interpolation formula. Okay, but before applying, we have to fix the digits in the calc as 2. See, remember, here we have to go as per the given numerical. If the decimal places in the numerical are 3, then you have to fix 3. If the decimal places are 4, then you have to fix 4. If decimal places are 2, then we have to fix 2. In this numerical, there are 2 decimal places, so we have to fix the decimal places in the calculator as 2, right? First of all, we are writing here x and xn. What is our x? See, 4.25 is our x, and xn. xn is the last value of x, so this is my xn. Okay, what is the formula to find p here? X minus xn upon h. What is the value of h? See, h you can see here the difference in the values of x, that is 0.5. Okay. Now placing these values, I can write here 4.25 minus 4.5 divided by 0.5, and this will give me minus 0.5. So this is my value of p. This is my value of p, so p is equal to minus 0.5. Okay, what is our next step? We have to draw backward difference table. Okay. So to draw the backward difference table, we have to first of all write here x, then y, nebula, nebula square, nebula cube, and nebula raised to 4. 4 differences because 5 values are there. Okay, let me write the values of x. It is 2.5, 3.0, 3.5, 4.0 and 4.5. See, remember you have to leave a space between these values, right? We have to leave a space. 9.75, 12.45, then 15.70, 19.52 and 23.75. Okay, now find the difference and write here. This is our nebula Y1, 12.45 minus 9.75. My first value will be 2.70. This minus this, so that will give me 3.25. We are writing in the center, right? Then this value will give me 3.82, then 4.23. Okay. Then difference of these values and write in the center. 0.55, 0.57 and 0.41. Again take the difference. It is 0.02 minus 0.16. Then again calculate this, you will get minus 0.18. See, the thing that you have to remember here is, in backward interpolation formula, we have to take the last value of the table. What we were doing in the Newton's forward interpolation formula, we were taking the first value. Here we have to take the last value. See, this is our last value of y, then nebula, nebula square, nebula cube and nebula raised to 4. So these all values we have to take. Okay, what is this value? This is my yn. This is my nebula yn. Nebula square yn, okay. Nebula cube yn, and this is my nebula raised to 4 yn. I have to place all of these values in the Newton's backward interpolation formula. How we can write the Newton's backward interpolation formula? See, I am erasing this. Let us write the Newton's backward interpolation formula. I can write here y of x. See, y of x or f of x all are same. Yn plus p nebula yn plus p into p plus 1 upon 2 factorial. Nebula square yn. Then p into p plus 1 into p plus 2 upon 3 factorial. Nebula cube yn plus p plus 1, p plus 2, p plus 3 upon 4 factorial into nebula raised to 4 yn. There is no need to write further. Okay, then we have to place all of these values. Okay, what is my value of yn? Yn is my last value. Okay, so it is 23.75. Then p, what is our p? Minus 0.5. So minus 0.5 into nebula yn. What is our nebula yn? 4.23. These are the values of the table. Okay. Minus 0.5 plus 1 upon 2 factorial is 2. And nebula square yn is 0.41. Okay. Plus. See, then we have to write minus 0.5 into minus 0.5 plus 1 into minus 0.5 plus 2 upon 3 factorial is 6. And nebula cube yn. Our nebula cube yn is minus 0.16. And then we have to place the value again, minus 0.5, minus 0.5 plus 1, minus 0.5 plus 2, minus 0.5 plus 3 upon 4 factorial is 24, multiplied by the last value, that is minus 0.18. Solve this whole in a single step by using the proper brackets in the calculator. Okay, if you will use proper brackets, then it can be solved in a single step. See, after solving it, you will get the answer as 21.60. Okay, how we can use the brackets? See, if this value I have to write in Calci, then what I can do? A bracket, okay, a big bracket, then all of these values, then divide by 2, bracket complete, and so on. So by proper use of the brackets, you can solve this type of numerical in a single step. There is no need to find the individual term, right? You can solve it in a single step. Fine. So in this way you can solve more numericals on Newton's backward interpolation formula. We will come with some more numericals in the next lecture. Till then, have a good day.